On today's episode, we're going to talk about parallel circuits and how they work with Ohm's law to be able to calculate voltage, current, and resistance. So by the time you're done with this episode, you should be able to have a good handling of how to work with the formulas to be able to figure out any of the resistances on any of the branches for parallel circuits, find current, and find total voltage. So we always start out with our good old circle V over I divided by R here. Okay, so remember, Ohm's law, V equals I R. Alright, now also getting into series and parallel circuits. So in previous episodes, we were able to come in here and create a essential wiring diagram with the battery. And we had a load that was in series or in alignment with our other loads. Okay, so they're all one after another. We had essentially only one direction that our electrons were able to actually travel in. So this time we're going to end up going and creating a parallel circuit. So what that means is that when we go to draw this, we're going to have different branches that the electrons can choose to go to. So there's branch 1, and there's branch 2. So as an electron, you're coming out of the battery, you can choose to go to the lower branch, or you can come up here to the upper branch. Okay? And that's going to change how we actually calculate our parallel circuits in comparison with our series circuit. So let's go ahead and get into this. We have a 12-volt battery as an example, and we have a load up here for 2 ohms, and let's say we have 3 ohm load down here. We want to calculate what the total current is going to end up being. Alright, so let's go ahead and get into that. And the biggest thing to start off with is to realize that because we have 2 branches, we want to calculate the branches separately. Alright, so in this case, if I want to find the total current, or the current for branch number 1, I would end up simply going V divided by R, like I normally would, and that's going to end up equaling 12 volts divided by 2 ohms. Okay, and 12 divided by 2, 6 amps. So this top branch is going to have a total of 6 amps. Let's go ahead and get a different color here. And then now we want to calculate the current for our second branch, which again is V over R. So 12 volts divided by 3 ohms is equal to 4 amps. So the total amperage for this, 4 amps. Which leads us to another idea here. I'm going to pick a different color quick, just to say that the lower the resistance that we have, the higher the current that we're going to end up having. So you can see here that 2 is lower than 3, but it has a higher current than this branch. Okay, so this is going to be important to understand the relationship, how resistance and current is going to be opposite of one another. Okay? Alright, now, how do we calculate our total current from this? Well, that all goes back to another formula that we can understand, or at least a principle, and that's going to end up being, if I have total current, all I need to do is add all of the currents in each branch. So if I have two branches, I'd add that up. If I have 3 branches, all I'd have to do is add that up. So let's go ahead and do that real quick. So we have total current equals 6 amps, because that's my current in branch 1, plus total current in branch 2, which is 4. So then I'm going to get 10 amps total. And that would end up being that answer. So pretty straightforward on that regards. So let's go ahead and again erase some of this stuff, and we'll calculate another example for you, so that way you can kind of get a grasp of what we just did. Okay. So we'll come in here, erase that. We'll erase that and that as well. Alright, now what we're going to do is we're going to actually add a third branch onto this, just to spice up things. Okay, in this case, let's see here, we're going to go red again. We're going to have 4 ohms, we're going to have 2 ohms, and then we're going to have 3 ohms. Again, we're trying to calculate current, okay, in amps. So again, we got to figure out the branch for 1, branch 2, and branch 3 current in order to find our total current. So we can just come in here and write down total current is equal to I1, and remember I equals V divided by R, so I could just simply say I1 is going to be 12 volts divided by 4 ohms plus branch 2, which is 12 volts divided by 2 ohms plus branch 3, which is going to be 12 volts divided by 3 ohms. Okay, and then I would just end up calculating this stuff out. So 12 divided by 3, or excuse me, 12 divided by 4 is 3, plus 12 divided by 2 is 6, plus 12 divided by 3 is 4. So in this case, our total current in our circuit, 13 amps. Okay. Alright, let's do one more process here, but let's not calculate out current. Let's calculate out our resistance for one of our pieces here. Alright, let's go ahead and erase this. Okay, so in this case, let's say we have a total current of 30 amps. And we have up here, we have a 3 ohm, here we have 6 ohm, and down here we don't know exactly what this is for resistance. We got to figure that one out. Okay, so again, getting into our formula here, we know that we would want to first start out by calculating out our individual currents in here. Then we can use our current for R3 to figure out our resistance for, current is I3. Once we figure that out, we can figure out R3. So, what is our current for R1? Okay, let me put up here R1, this is R2, and this is R3. Okay, so I1 is going to be 12 volts divided by 3 ohms. Okay, so that's current for 1. So that's going to equal 4 amps. Alright, our current for 2 is 12 volts divided by 6. So that's going to end up being 2 amps. And then our third one, 12 volts divided by something. Okay? So 4 plus 2 is 6. So I know that R1 and R2, excuse me, I1 and I2 is 6. And because I know that the total branches added up is going to equal the total, all I would need to do then, actually, I already know the total, so let's write down the total. That would be 30 amps. So I1 plus I2 is 6 plus I3, because I don't know it, right? Then all we'd have to do is subtract 6, and I3 is going to end up equaling 24 amps. Alright, so we're not done quite yet. We know that this is 24 amps. Now we can end up going in and calculating out our third resistance. So R3 is equal to the voltage, so 12 volts, divided by our resistance, or excuse me, divided by our current, which is 24 amps, and R3 is equal to half an amp. So that's how we can actually go in and do that. Alright, so what do we end up learning in this episode? We learned how to obviously calculate out our amps, how to calculate out specific resistances using our Ohm's law, and understanding that all the currents added together equals our total current. This can also allow us to then end up calculating voltage as well. We would just have to end up syncing that up with our V equals I times R. Alright, we'll catch you guys on the next episode. Again, if you have any questions, feel free to email me, and we'll see you guys later.